So, we have been talking about air jet texturing, and today we will go a little further and talk about something called interlacement, the need of such a type of a process, and anything to do with the jet. So, if you look back, what we have done is we have understood the mechanism of bulk development in air jet texturing, the design of the jet, the features, for example, converging, diverging type of jets, flow asymmetry, withdrawing the yarn at right angles, roll of a baffle plate or bar, and also single core jets. We also learnt about wetting, so edge texturing and its role, and also how some of these design features have helped in reducing the instability and maybe the consumption of air. So, the interlacement is another process which in some sense can be considered as an offshoot of the air jet texturing. What exactly and how exactly it is different, we would like to understand today. So, sometimes the terms could be entanglement or interlacement, they mean the same thing. What it means is the filaments have entangled or they have interlaced. The yarn that have been subjected to this process could be entangled yarn or interlaced yarn, or the jets which are also used for this process are called interlacement jets or entanglement jets. In general, twisting of the filaments is done. A parallel bundle of filament in general is not processed, because if individual filaments get separated, then they can get entangled with machine parts or guides or adjacent yarn on filaments, which obviously is not a good idea. Therefore, filament yarn industry believes in giving some amount of pre-twist, very small, just to ensure that these filaments do not get separated, and that is the norm. The separation could be because of mechanical dislodging. You remember, we apply a spin finish, and one of the aim of the spin finish is reduction of the friction, of course, reduction or elimination of static charge generation, and also hopefully keeping the filaments together. Some type of a cohesive bonding should be there. But it may not happen because you are processing, winding, unwinding, passing through guides, and it can happen that the filaments can get separated. Let us say 36 filaments in a multifilament yarn, they get separated, then one of them can be really behaving in a different way, and so it can cause more problems. The other could be that though we believe that the spin finish would be working the way it is supposed to work, but it is quite possible that it may have been removed or is not as effective if there is any electrostatic charge generation during this process, then they can also get separated. Not necessarily every filament is different, but from wherever they are, the portions of the yarn can get separated and then they can get entangled. So, these separated filaments, because of these two reasons, dislodging mechanical or electro splaying, can break after entanglement with the neighboring filaments or machine parts, a knitting machine for that matter, can break the yarn. So, there can be faults in the fabric, or knitting needles for that matter can also be damaged. And so, all these things are something which people would not like to have it, and therefore, you may like to give a pre-twist. So, this need that the filament should not get separated was a real need, and therefore, people thought about another process which we call now as interlacement. It is for multifilament yarns. This is not a problem with spun yarns. So that the above problems are not there, they do twisting. But twisting, as we know, is a batch process. So what you have whatever material in whichever type of a package you have to take through a twister and make another package. And this is a costly process, a batch process, a costly process. But if there is no alternative, then you do it. Therefore, the need for the interlacement came, that can we avoid the twisting process and get the same effect, same result, meet the same objectives. This is a continuous process, in general expected to be cheap and can be fitted on attachments, could be put on any other machine, any machine, and so online work can be done, then monitoring can also be done. So, that is how we come to a process called interlacement. So, we did mention that as if you are working on edge texturing, where entanglement was one of the parts of the texturing process itself. So, how is it different from edge texturing? Do we use jets? Yes, we use jets. So, this process of interlacement is accomplished through the jets. Do we need a compressed air? Yes, we do require compressed air. So, how is it different? So, you require jets and you have compressed air. So, how is it different? So, we are not interested in development of bulk. That is one difference, that our aim is not to develop bulk. And why was the bulk developing in an edge textured yarn? Because we are giving overfeed. So, one important difference that we have is we do not want to give any overfeed. If you do not give any overfeed, then bulk may not be developed, because you are just interested that the filaments somehow stay together. So, this so called interlacement, is it a continuous interlacement or is it intermittent interlacement? So, that is in some way defining the interlaced yarn structure. So, theoretically, we are not interested that every part of the yarn is interlaced. If some parts are interlaced, we could be happy. So, if something like this happens, at some places they are together, we will be still happy. Other is that we continuously, every small little millimeter of a yarn is interlaced, can be done, but should we need it or not? So, if you take some yarn like this and actually subject it to electrostatic charge, so you might see that there are portions which are not interlaced and there are portions which are interlaced. Now, this yarn in normal condition may not look like this, because you are not given any overfeed. It is only when you have tried to separate them out, all right. But what is important is that you do generate what we call as nodes. So, you have these nodes. So, in general, some simpler structure like this is required. So, obviously, maybe you do not require high turbulence, maybe you do not require high pressure, but actually people thought that they would like to make these jets as simple as possible, because this is just some work. It is expected that design would be simpler and the jets could be completely open or closed. So, they tried everything. Open means what? Open means that there is a plate and there is a yarn and direct impingement is taking place on the yarn itself. Just in something should happen. So, it is not closed. Closed one would be something similar, where the yarn is passing, it is inside a channel or a orifice. So, you have a cylindrical hole, so it is closed and the compressed air is being impinged. So, these are two things which you tried. Obviously, people very easily understood that in an open system which can be done, but you consume more air, get less effect, the yarn can have a tendency to go away from the impinging point, and so it may not at all come into play. You may have to give more tension. You can appreciate if you give more tension, then interlacement will be difficult. And so, he said it may be a better idea to have some closed system, where there is a control, the yarn is inside something and impingement takes place, and whatever effect that we are hoping would be there. So, actually people tried many types of designs, and one wonders as to something which you wanted to be very simple, also people wanted to have more design. So, one is a design where there is a little notch out there. So, if the yarn comes like this, is going to be pushed in. The notch could be very small, notch could be larger. So, people want the effect to happen there. In some cases, they had through and through hole for the air while the yarn is moving like this. All of them would have a different impact on the impingement during the impingement part, but they tried. They called it direct impingement. Direct impingement means the air is directly, almost perpendicularly impinging, so that whatever happens should happen there. Indirect impingement, where the air is directly not impinging, but is being fed in different ways and causing some effect while the yarn may be moving. So, coming think of it, appears people were interested in this process so much, they were looking at some results which were probably not coming as easily. One of the things they were obviously interested is that you are interested in intermittent interlacement and not continuous interlacement. They were looking at various kind of things. Almost similar to the airjet single core design also were tried for this. So, what do you remove? You reduce your pressure and do not give overfeed, or if at all somebody says if there is no overfeed, then maybe effect is less, it gives a little bit of an overfeed. So, directly it is not impinging on the yarn, it is actually coming in one way or the other and then trying to work. This whole process, people thought that you can actually have an actuator where the air is being impinged directly onto the yarn in this manner, but is pulsating. So, you have a control. When the air is there, there is an interlacement, there is no air, there is no interlacement. So, if you see that so many people wanted to try so many types of designs, so that you get what you want to get. And then they tried things like this. So, typical process may be where air is impinging in this manner, very simply in a closed system, maybe by pulsating compressed air. So, you have, let us say this is a textured yarn, you could have called it a flat yarn also. Now, this textured yarn would be which one, air jet or false twist? False twist. Why not air jet? We know the need. So, why not air jet? This is the input. Why not air jet? Because the air jet yarn is already entangled. It does not need any support. It is only such type of filament yarns where the filaments can get separated. Those type of yarns are the only ones which would require this additional either pre-twisting before processing into a knitted or a woven material, or a flat yarn which is either textured or a flat yarn. And of course, there is compressed air, and then you hope that there are interlacement points, and so this is the way you expect, and this is a typical process people will be expecting. What is also expected is that can you change the speed of the machine based on the requirement of this jet. Let us say I run it very fast or run it very slow, and air pressure is same. Though the time required within this jet will be based on the speed. So, effect can be different. That is a common normal logic. The question is, can we change the speed based on the need of this interlacement jet? We would not be able to do that, because this is a supplement, an attachment to the main machine. Let us say you are producing a fully drawn filament yarn. So, you do drawing or you do heating if you need to, but that will be decided on the drawing machine, but you want some interlacement to happen also. So, this will be an attachment put in the machine, let us say just before winding. So, you can play around with compressed air as long as you know what is the design. Design is fixed, but you will not be able to play around with speed. So, time is not something in your hand, and overfeed anyway you said you do not want it. So, there is only one parameter, and therefore, they also thought that design becomes an important thing in what to do. People also thought about method how to feed the yarn. So, if there is a cylindrical thing, air is coming, can come from this side. So, if you should be, if you can rotate this portion which is inside a block, then the yarn can be fed from this side, let us say vertically going in, and then you rotate it back, and so the air comes from here, the yarn is somewhere here. And so, people designed these things also, but in the mind there was only one thing which was important, that we are interested in very less amount of interlacement and also intermittent. After various kinds of designs were done, people were wanting to understand what would be the mechanism of interlacement. So, one of the mechanism which they thought would work, should work, is called a plating mechanism. Plating mechanism means you divide the whole bundle into approximately 2 parts and separate them out, do a bit of a twisting, and then bring them together. So, these bundles can twist over each other, and it is like a plating. So, it is different than the air jet texturing. There you wanted every filament much separate. They say may not be required as long as they remain intertwined. So, let us say you have a multifilament yarn and it gets impinged by air, let us say it is passing down, and when it gets impinged, that time let us say you get separation of filaments, and if you have some mechanism with which these two things could be twisted in opposite direction, and then the filaments are anyway going down, and they come together, and then they plate come together, and the yarn is going down. So, what happens when you twist one portion and the other portion? So, wherever they are together close, they would like to make a node or a plate or a twist. So, the twist can form here, the twist can form here, because they are close, they can overlap, intertwine. So, when the yarn is coming down, this portion anyway goes out, this portion is now little more compact. As it moves into this zone, it does not open the way you like to open. When it comes to this zone, this portion, when it comes to this point, it cannot open because now it is interlaced. But as it passes down, then you have filaments which are parallel bundle, they are not, then they will get separated and again twisted in 2 different directions. So, you have one node being generated below, one node being generated above, and then it passes. So, what they find, if at all, if you can make a jet which will do this thing, separate the bundle into 2 portions approximately, twist them in opposite direction, and then bring them close, which anyway will happen. Then if this happens, then you will get nodes intermittently. It is passing at a particular speed. Whenever a portion which is like a node passes, it does not open, it just passes. When bundle, uninterlaced bundle comes into this area, it gets separated, maybe get twisted, and then a node on the top and the node on the bottom is being made, and then it goes continuously passing. So, what it says is, without any sophistication, pulsating jets or any other thing, you can create an intermittent interlacement if something like this happens. And this period of interlacement would depend on the pressure, would depend on the vortex being generated, and would depend on the speed of the yarn it is moving, although you have no control, but will depend. So, the question that remained was that what would happen? A simple design which looks like here of a jet, it was expected, maybe the air stream is coming, as it comes into an expanded zone, then it makes some kind of a swirl, this one goes there and makes some kind of a swirl, and the portion of the yarn which is separated, if it is here, one portion here, other portion here, then they will be twisted in different direction, if this is true, right. So, air stream enters the jet and then goes like this, and so you have a portion of a yarn which may have been separated and brought into this vortex and the other vortex, and then when it goes in and comes out, it will again have this mechanism with which they can make nodes intermittently. But what was important is that they must separate and twist. It is like a false twist, there is no real twist, but when they come, they twist over each other because they just come together. So, they said very simple, so let us have this design. So, this design they tried to do, they did not really find very nice intermittent nodes being formed. Something was happening, but maybe it was not as good or appeared to be continuous change, or was not good enough. So, what they found was happening. So, this is your simple jet. So, expected was that this would happen, something like this would happen. It did not happen. Why? Because expansion of air was not dependent on the desire, it just would happen the way it has to happen. So, parallel streams, let us say, are coming, they go and they strike a wall and they can get reflected. So, instead of going, they were expecting they go like this, it may actually happen this goes and like this. So, instead of having separate whirlwinds, they would get reflected in different ways, and so turbulence gets created. So, it is not helping. They may get separated, but there is a turbulence, so it can happen, all kinds of things can happen. So, that condition that they should get separated and get twisted in different direction would happen. So, somebody then thought of same design a semicircular or a part of a circular cross section, part of a circular cross section, not the whole circle cross section. Then what they found is this can work, and how it work, that this goes, before it strikes the other wall and goes like this. So, this goes like this, if it is expanding, then this goes like this and not like this. So, if it is on this direction, it will go this way, if it is here, it goes like this. So, what people found, that if you just reduce this, you can actually get this swirling action in opposite direction. So, if someone thinks, well, this is just a design, very simple, you can always do it, but it took good number of years and good number of people who were already making jets to understand requirement is different, we want a different thing, maybe this. Finally, today a jet of interlacement jet would be something similar. That is, you want to separate the filaments, twist them in opposite direction as it comes out. So, the design is like this, semicircular, and you see a different color. So, this is a plate. So, instead of the threading becomes easy, so there is some kind of a plate, we just remove it, it can be moved on one side, hinged or pivoted, and then you can pass your thread and then close it. So, finally, the design is very simple. Started with all kinds of hypotheses, then trying to say what do we want, and then trying to get to this most simple design which works. So, you can appreciate that whenever somebody is trying to design a small thing or a big thing, there is a science behind the whole design process. This cannot be let us do it. So, it may start with let us do it, but finally it will not. So, now that you have done, let us say, some design which can produce intermittent nodes, you do evaluation after all and characterization. So, there methods have been suggested, how do we find how many nodes are there. So, one of the method is called the needle method, other is needle method, as it says, there may be a needle which is moving to check it out. Electrostatics playing is that you actually charge them, so that wherever there is no node they will go further, optically you can find out. A mechanical bead test, it is expected that if you put a bit of a load onto the yarn, the nodes will be more denser compared to the uninterlaced area. So, it is like a bead being formed, that if there is a sensor, it will probably move up or down based on whether there is a node or there is no node. So, you did have ways in which you could do that. So, needle means that there is a needle which may be here. When it is impinging needle going like this, so there is an open area goes down, a closed area comes up. So, this motion would be monitored by this LVDT type of a transducer, and then you can count how much down, how much up, It's happening. So, just a needle, the yarn is continuously moving at a certain speed and a needle is just resting on it. So, it goes up, goes down. So, difficulty obviously is that based on what actually the yarn structure is, the needle might actually get stuck also, goes deep and then suddenly something happens. So, or you can't increase the speed very much because needle has to go in and come out, all right. So, although at a slow speed this method would give the same results, at higher speeds needle may get damaged, because much before the needle could go, the yarn would be going faster and may bend it. Although it's a very, very low pressure type situation, but still it has to get on. So, electrostatic splaying was obviously optical method. So, you have to have your systems which can optically see there is expanded portion and non-expanded portion and count it. So, it can also be done very slow speed or you can go fast speed depending upon how quickly your system is analyzing your data. First record and then analyze, but there has to be a process. So, this is one which people have made machines on. You can appreciate that somebody wants to make machines to evaluate something called an interlaced yarn. So, interlacing must be an important process also. If it was such an unimportant process, why would people work around this and find it's an important thing. We are replacing twisting. A mechanical bead based testing equipment could be a kind of a cantilever with a spring, where if node is there, diameter, the distance will be different. So, it is not this plate, which is this plate, is not going inside, it is only compressing. So, there is no entanglement here. So, it is just there with a under pressure, goes up and down as it moves down, and you can measure this. What do you measure? Number of nodes per unit length and also average length between the nodes. For the same thing you can calculate these and give the data. Stability. How much stability of these so called entanglements do we want? When we are looking at the air jet textured yarn, you are very, very sure that should be very, very stable. Now, it should also be stable, but how much? You see, like you have crimps in the fibers so that you can make it twisted yarn. So, the role of crimp is known, but does anyone interested, is someone interested that the crimp should be permanent, very strong, or they said ki after I have made the yarn, if the crimps go, I have no problem. It was only in the intermediate process that you were interested. That is what happens. Here also you are interested in the stability to an extent that you should be able to make a knitted fabric or a woven fabric. After you have made the woven fabric, now you have many ways of binding these yarns, all courses, veils, So, the interlacement takes place in a woven fabric anyway. Then the filaments can't run away and you have done made a fabric already. So, purpose of this is served as long as you are able to, after that some of them open, you do not mind. So, people would do some testing where yarn over yarn friction, under tension you pass over a wedge and see the previous figures. How many nodes are now left and what is the average length between the nodes. So, what would happen is that you pass the yarn under tension, which would be, let us say, a weaving tension or a tension knitting machine, whatever. So, based on those kind of values, you pass this yarn, and if they open, you will know how much have they opened. So, what have we done? We have done what is interlacement, its need, type of a jet that may be used, mechanism of interlacement, evaluation. It must be remembered that these are the devices which will be added, attached to the main machine, whether you are producing a draw twisting, false twist or bulk continuous filament yarn, because their filaments are supposed to be free. So, you do not want the filaments to be so free that it is difficult to control. There we are.